Hi, I'm Aaron Stash with the Electric Home Show. We're here in Downers Grove, Illinois with Tim Molsky, and we're going to learn about his hybrid HVAC system. I'm Aaron Stash. Welcome to the Electric Home Show. Tim, good morning.
Morning, Aaron.
Good to see you.
Good to see you.
So tell us about your house and what you've got going on.
Sure. My house is 13 years old, and the legacy furnace air conditioner unit was on its last legs. So I was going to replace it, but I was fortunate to go downtown Chicago and visit the Climate Action Museum, and I learned about heat pumps and electrification. And the first step to explore reducing like carbon footprints, having a comfortable home was to start with Rewiring America.
Okay.
So I went there and I looked for people to help, and that's how I found you.
Great, great. Yeah, Rewiring is great. Yeah. But let's back up a little bit. There's a Climate Action Museum where you learned about heat pumps?
Yeah, so they just take you through like things we can do with insulation, heating, windows, that type of thing to make a difference, to save on efficiency and also try to help the environment where we can.
That's fantastic. So really looking at updating the HVAC systems, and you could have just changed it into another gas furnace and an air conditioner, but you went the heat pump route.
That's right.
So talk about that.
I do data analytics for a living. So yeah, I modeled out the legacy scenario, a straight heat pump with a backup furnace and geothermal, looking at past temperatures, past therms, past energy usage, kilowatt hours, all that stuff.
So ultimately, when we first met, you were thinking about going all electric.
Right.
And I know in this system, we're going to see a hybrid system. So how did that come to pass?
Yeah, so that, unfortunately, Chicago still has such cold weather. So even though that I learned the cold heat pump could keep us warm, just for periods of polar vortex, extreme cold, the amount of electricity usage we would have had to draw for that didn't seem right. So unfortunately, we had to go with the backup furnace for those situations.
Right.
Yeah, and with my model, I think modeling below 20 degrees, the furnace kicks on, I'm still saving the equivalent of planting 144 mature trees every year. So that made me feel really good.
And you've done some other work in the house. You did insulation and some air sealing. Are you planning to do additional electrification or decarbonization
so
upgrades? As
things expire, like our existing stove and oven, that's still gas. I'd love to turn that out. You had the idea of, if I don't want to do the 240 volt, I could potentially get the one with the battery. That's fascinating, so I'm going to look into that. Hot water heater.
Yeah, so really quick, what Tim's talking about there is an induction stove that has a built-in battery system, so you can just plug it right into the wall. You don't need to upgrade your electrical infrastructure or things like that.
Yeah, and you also helped me recommend getting an air quality monitor, because I didn't have that in the house, and just seeing the EVOCs kick up, so the volatile organic compounds, when we're cooking, right? Even though we've running that exhaust fan, that was really...
Yeah, pro tip here, everybody go out and get an indoor air quality monitor. I think it's one of the things we don't think about. But things like water heaters, and we talked about hey, if it ain't broke, don't fix it.
Right.
But now you've got kind of a plan.
Correct.
Yeah, and in your home, we did a load calculation. So we did the 3D scan of the home to really dial in your heating and cooling for the heat pump. And then we're able to pass that on to the HVAC contractors to find the right system. Thanks for watching the Electric Home Show. If you're a homeowner interested in a healthy, energy-efficient electric home, reach out to us at electrichomecompany.com to schedule your free virtual coffee today. Thanks for watching. So Tim, we were just talking about the payback of this system. And oftentimes I think about, hey, if I'm gonna remodel my kitchen or put in a new bathroom, people aren't really thinking about the ROI of that new countertop. How did you make this decision financially or for other reasons? What does that mean to you?
So from a financial perspective, there was more money from me put down. And again, we talked about getting some rebates, some incentives back from the government, tax credits, but it wouldn't necessarily on paper just match up to just replacing the legacy system. However, over time, and it'd be a number of years investment, we'll get some of that back from savings on air conditioning and savings on natural gas costs, which are very volatile. Those can shoot up at any point in time. But a lot of it is the environmental sustainability. I talked about all the carbon dioxide tons that we aren't emitting, that means something to us. And we're doing our part.
And really hard to put a price tag on that.
Yeah, and clean air.
Absolutely. No, hey, thank you so much.
All right, thanks for your help.
All right.
Appreciate it.
I want to cook it low and slow for as long as I can.
Correct.
And that's
in this case, we are the meat.
Yeah. We are the meat. Hi, I'm Aaron Stash with the Electric Home Show. We are down in my favorite room, the mechanical room, with Franco Barbagallo.
Hi, everyone.
Good to see you.
Good to see you, Aaron.
So tell us a little bit about the work that you do, and then we'll jump into this. So where did you get started?
So I've been doing heating and cooling for about 13 years already. Time goes fast. My specialty is what we're looking at, high performance heat pump systems.
On this project, you were the HVAC designer, so you and I talked about the load calculation for this house that we did and then sizing the system. But before we get there, let's talk about when we were originally started, we wanted to go all electric. Now this is not an all electric system, and there's some reasons for that.
With a catch. So depending how you look at it, it is an all electric system if you want it to be, with the flexibility that when it gets really extreme temperatures, you have a gas backup. And the main reason for that was really ductwork.
So talk a little bit more about that. So we were changing out an existing gas furnace and air conditioner in this house, the house that's about 12, 15 years old.
Correct.
We have existing ductwork overhead, and we're like, oh, we'll just swap in an electric system, it'll have electric backup heat, but it's not that easy, right?
Not quite for everybody. All electric requires some considerations with the airflow. So just a simple rule of thumb, to not get too complicated, is for every ton of cooling, about 400 CFM, cubic feet of air per minute, of airflow move through the system. When you're doing electric heating, now your heating is the same math as cooling, or very similar. You need more air volume.
And so different from a traditional maybe gas furnace, because we're just blowing a lot of really hot air really fast.
It's higher temperature, so put it in this way. In this amount of air, you can fit this much heat at this temperature. Furnace is running at a really hot temperature, call it, depending on the furnace, 160, 180. The heat pump is a lower temperature, which means you need more air to put the same amount of heat.
Got it.
So if you don't design it correctly, you might end up with an advertised efficiency that sounds really good. It might still work. It'll do the household heat, but your energy cost might be a lot higher. The equipment might suffer. So it is important to take a look at that. In this particular case, to go all electric and being able to achieve that peak efficiency and eco-friendliness, we would have had to add about 300 CFM of airflow, which in a finished home, sometimes it's easy, sometimes it's not, but that would have required cutting some floors, walls, and a lot of extra costs.
Ultimately, a lot more invasive for the homeowner to have to change out.
So it's not just price, but it's also, are you willing to go to do the work?
But then in this instance, so we've got a hybrid system, so we're still using the heat pump for heating.
Absolutely.
How low outside temperature, so it's November right now, it's about to maybe snow over the weekend.
Correct.
How low of a temperature can this heat pump continue to run?
And that's the key, this heat pump. It depends on what unit you have, but in this case, we have a Lennox Signature Collection system, which is the best Lennox has to offer. So it's the Lennox SL22 KLV. That is a full-blown cold climate heat pump. Years ago, those were only available from Asian manufacturers, but time changes. That is one of the most efficient heat pumps in the market. That heat pump can give you 100% capacity at 5 degrees outdoors, and it will continue to work down to minus 22.
And then we were looking at the thermostat upstairs, and we were looking at the balance point. So it knows, or you can program, or the homeowner can program when we want the system to switch from heat pump to gas. But there was also an interesting piece where there's a bit of an in-between where it might choose to do gas or heat pump.
So this particular system, it's what is called communicating. What that really means in simple terms, this is a lot smarter than your traditional heat pump. Communicating really means that the entire system is analyzing each component's performance, monitoring outdoor temperature, indoor humidity, and homeowner setting, putting all that together and very precisely choosing whether to use heat pump, furnace, at what speed compressor, what speed airflow, how much humidity. So there's a lot of settings that you can set, but the system is really smart in how it does things. Humidifier, just engage on us. We'll talk about that.
Yeah, let's talk about that. So there's a humidifier system on here. It's a pad humidifier, correct?
Correct. This is what it's called evaporative humidifier, so it relies on evaporation. It's a really smart humidifier.
And you were saying to a certain extent, like it knows if I need 6% humidity or additional 6% or additional, how does that work? Like it's all these different sensors in the system, in the home?
So basically, the Lennox Signature heat pump has a built-in outdoor temperature probe or sensor. It knows the outdoor temperature in this location. It knows the indoor temperature, and it knows the homeowner preference for humidity. So it's going to calculate the dew point. And it also calculates what is called the feels like temperature. This thermostat, instead of operating like a regular thermostat that tells you the temperature.
Well, and let's talk about that feels like temperature. So I think oftentimes we think in summertime, if it's really humid, it's going to feel warmer.
Correct.
You know, or in winter, if it's really dry, I'm going to feel colder. So I might be able to change my thermostat setting based on what my humidity is.
And with this system, you don't even need to do that. So the system has a feature called feels like,
Okay.
which we always activate. And basically the system knows, hey, a homeowner, a human, if it's 71 degrees with 10% humidity, this person is going to feel around 69.
Yeah.
So maybe if I just increase the humidity to the preset preference, you can feel the comfort you want without me overheating 2 or 3 extra degrees. That results in instant savings. Every degree you lower your temperature, according to the energy companies, could be anywhere between 3 and 7% in your energy bill. So having a humidifier that really knows what it's doing can mean 5 to 15% in savings.
Wow.
So humidifier is really a really good investment. Plus, it's healthy to have one.
And in this overall system, were there other updates or changes that the homeowner needed to do? What about like the electrical panel? We're putting in a heat pump system.
I'm glad you asked that, because that's a big misconception. Oftentimes, homeowners that are not as aware of heat pumps, or even contractors, talk people out of them. It's a lot of electricity. Heat pump and air conditioning are really almost the same unit. You wouldn't be able to tell the difference. And in this case, this is a 3-ton heat pump. The air conditioning version of this unit, which looks exactly the same, uses the same breaker.
Okay.
Because it's basically
So
the same
no
air conditioning.
changes to the electrical panel at all in this instance?
For most people, no.
And the only case, maybe if he had gone all electric and done the ductwork and things like that, you might have put electric resistance in.
A backup
and
heat.
that would potentially take additional...
That would be a new 220 line high voltage to a backup heater. With a system like this, since we got here, about an hour ago, the system never stopped running. It's been running all the time. You don't hear anything because it's extremely quiet, but it's, that heat pump right now is probably running at about 18% capacity.
And that's interesting because...
Steady. It's trickle heat.
I would think that, it's running all the time while I'm using all this energy and electricity, but like, that's not actually the case,
It's
right?
quite the opposite. So when I talk to homeowners, that is an argument that I always get back, and my answer is always, let me help you answer the question by yourself. If you were to shop for 2 used cars, same car, the same model, same year, same mileage, and I'm going to tell you, same price. This one has been used by FedEx to deliver packages in the city. This one was 100% highway miles. Which one you buy?
The highway miles.
Everybody answers that. And when I ask them why, they're, well, I guess because it was more efficient and it didn't start and stop. When is your car gets the better advertised miles per gallon highway? But you're driving all the time. How come? Right. So once you think about it, it makes sense. Start and stop is where you waste all the energy.
Well, yeah, and I think we've been, programmed by our thermostats to do these set points and pull these
Which
things
means
back.
nothing. Because
but really, we want to set it and forget it in the case of a heat pump.
Correct.
And, I like to compare it to a barbecue, right? I want to cook it low and slow for as long as I can.
Correct.
And that's
in this case, we are the meat.
Yeah. We are the meat.
But it's a fully variable speed inverter compressor. It's very steady. The main goal is really for you to be comfortable without knowing what's making you comfortable. With a traditional system, you're going to know it's running, it's not running. With this, you're just enjoying your life, being comfortable in your own home, sleeping cozy in your bed without pulling your blankets in and out, without knowing why. That's really the comfort. For this to be like a really nice butler.
Perfect.
You don't know it's there.
Well, thank you so much, Franco. It was great to do this collab with you.
My pleasure.
Like and subscribe for more.
I'm Aaron Stash. Thanks for watching The Electric Home Show. Like and subscribe for more.
If you're an industry professional interested in joining our network, reach out to us at electrichomecompany.com. Thanks for watching.